Okay. Uh, hi, Karthik. So let's start. Actually, let's resume the sessions. Okay, again. So to start with, today we are going to study the first ML algorithm. Fine. So it is linear regression. Am I audible? Is my screen visible,
Yes,
Karthik?
sir.
Okay, fine. So are you getting any background noises?
No.
No, right? Okay, fine. Uh, Fine. Let's start. So, as I said, so today topic is about the first algorithm. Uh, it's called linear regression. Okay. So linear regression is a supervised, as you know, in the ML, we have mainly supervised and unsupervised, right? So over here,
Yes.
have regression and also you have classification. This we are aware of.
Perfect.
Okay.
Yes.
So what is the basic difference? If the output variable is in the form of numerical nature, so that comes under the regression. But if it is in the categories, that's a classification. Okay, simple.
Perfect.
And if the task itself is not to, do some classification, either in the form of regression technique or classification technique, so it is unsupervised. That means we don't have any classification task over here. We just need to do some sort of clustering. Clear?
Yes.
So just to
Yes.
revise you, here you are going to have X and Y both.
Yes.
Okay. So the basic thing is first you need to provide both X and Y input and also output to the model. So model will see the data. It will try to
Fine.
understand as per the algorithm, what are the algorithm you are using. Okay. It will get an understanding. It will try to understand the pattern between input and output. After that, if you give only input based upon its understanding, it will give you the output. That is called prediction. Okay. So this
Yes.
is a concept of supervised. But in unsupervised, you don't have anything as such. You just have the input data called as X. You just need to divide them into different groups. You can call them groups, buckets, or clusters usually. Okay. So that is regarding unsupervised. So this is aage ke baat. Now let's forget about this. Now let's focus on
Mhm.
supervised. In this also, the first is regression. In regression, the fundamental algorithm is linear regression. But that does not
Yes.
mean linear regression is only algorithm which helps us to achieve regression. There are many other algorithms also. For example, using decision trees also. We did not study decision trees, but there are different types of algorithms. Almost every algorithm have a regression flavor for it. Okay. I mean, we have using decision trees also, you can do regression. Okay. And using many boosting algorithms also, you can do regression. Okay. Using Knan also, you can use it for in a way for regression. Okay. So
Okay.
like that,
Okay.
many algorithms are there by which you can use it for regression. But the most fundamental and algorithm, the first algorithm is the regression. Okay. Uh,
Okay.
just mm,
Oh no.
yeah.
Hmm.
So that is regarding the regression. So over here, uh, linear regression, as I said, it is the basic regression algorithm. Okay. Now coming to linear regression. So let's see few points about the linear regression. So first and foremost thing is it is a simple algorithm, guys. Okay. It's a simple algorithm. It's simple. And second thing is, I would say, it is a bit, I would say, a lengthy algorithm because once you study linear regression, right? So there are multiple extensions to it. So like you have, for example, like you have from linear regression, you have something called as simple linear regression. Okay. Then you have multiple linear regression. Okay. And then you have polynomial linear regression. Okay. And
Okay.
along with this, you also have another extensions like we have a concept of regularization. So once you attach that concept to linear regression, So there are other forms of linear regression, okay, like Ridge and Lasso and Elastics. There are like different forms of linear regression are also available. So that's what I would say. It's not hard to understand, but it's a bit lengthy algorithm. I would say there are like there is so much scope to learn and many new things over here. Okay, so but this is just few different points about the linear regression. But coming back, what is linear regression actually? Okay, this is very very interesting because all this time we will be hearing, okay, machine learning, okay, machine learns, okay, we hear this type of words, right? But in this class we'll try to understand what does it actually mean, okay, when we say machine is learning something. But as now we can take it granted that, okay, machine learning is being used and we are doing many okay, wonderful things, etc. But since this is a first class, initially you should think like that when someone is saying that machine is learning, that itself is contradicting, right? Because humans are designed to learn, okay, machines are designed to work, fine. But we are saying machine learning, right? So that means machine is learning. How can a machine learn? Does it have a mind? Okay, no. See, there are few devices, like for example, you have a washing machine, right? So you have a logic already incorporated in that. So it is doing some work, okay, but it can do the same work again and again, okay? It is just following a set of instructions. Can we say that washing machine has learned something? No, we cannot say because it is not
No.
learning. It is just programmed. Okay. Same thing like your refrigerator or AC, something. It is just doing a specific task. But now when we are saying here the machine is learning something, so how can it learn? So that means like because the learning process is a very, very unique property for human beings. Okay, right from the beginning of the nature. But now we are able to induce that intelligence, okay, into the machines also. It is able to learn, it is able to, find error, it is able to reduce error, and it is able to give you some results. That is very very fascinating, and that is a fundamental idea over here. Okay, and we will be saying that, and we will be convinced that how machine has learned something and how it helped us to achieve some results. Okay, cool, that's a basic background about it. Now moving forward, I would say, but here, just to keep things simple, so what is linear regression? As I said, you will be having just x, okay, and you are going to have a y. Simple. X is input, y is output. So given input, you will have a corresponding output, okay, only one input, one output. That is simple linear regression. Okay, coming to multilinear, and also I forgot to tell you, if you're not following anywhere and if you're having any doubts, okay, feel free to just pause me over there and ask me, okay, fine. So now coming to multilinear regression, okay. Multi sorry. Over here, what happens is you will have multiple inputs. Okay. So for example, over here, if I just give you an example, so you have you want to predict something called as salary. Okay, you want to predict salary, and input could be let's say is years of experience, or let's say CGPA. Okay, is score. So based upon the CGPA, you want to predict the salary. Okay, so that is a simple, only one input, one output. Clear?
Yes, Santosh.
Okay, but here over here, you want to predict again same. Why will always be one, obviously, right? So you are going to predict only one. You cannot predict three or four items at a time. Okay, so you are going to predict salary, but instead of only X, here you are going to have X1, X2, X3, maybe more. Okay, so this could be CGPA, that means his score. This could be his gender, and this could be his number of years of experience, etc., etc. Okay, so this become multidimensional. Over here, earlier I told you, if you remember, that each column, each feature will be called as one dimension. Okay, so this has become a multidimensional problem. Okay, so you are having your salary is dependent on three independent features. Okay, so that comes under multilinear regression. Clear?
Yes.
And after that, you are going to have something called as polynomial regression. Okay, so what is this? As of now, here in linear regression or multilinear regression, there is one fundamental assumption. Okay, we will see that, but one fundamental assumption is the data should be kind of linear. Okay, there should be some linear relationship between the data. What is linear relationship? If x is increasing, okay, y should also increase, or if x is decreasing, y should also decrease. Some sort of linear relationship it should be there. Okay, only then this works. That's why it's called linear regression. Okay, there should be some linear relationship existing in between the input and output. But what if there is no linear relationship between the input and output? Okay, that means what if the features are of higher order? Okay, so if like y is equal to x square, okay, so it's not linear. Fine, it is depending on the square of the x. So in those cases, we are going to use the polynomial. Okay, but we will see this later. Sorry. Okay, so this comes in later point of stage. Okay, but understanding multilinear regression is mostly dependent on the simple linear regression. If you understand this, it's just extension of thought, nothing much. Okay, are we clear? Any doubts over here?
No.
Okay, fine. So now if you see here, now let's try to understand bit by bit what is this idea of linear regression. So as I said, for example, if you're having a simple task, okay, we got CGPA and we are having salary. Okay, using this, I want to predict this. But fundamentally, before that, let's forget you have this data. Okay, so you went to office, and if you ask me, like, what should be the salary? Okay, what should be the salary for this particular person? Okay, what should be the salary for this particular person? I not have I I not give you any data. Okay, no data is given. I just brought you one person, and this guy. Okay, CGPA is so and so. Okay, and how much salary you can offer? If I ask you that question, then what will be your answer? You don't have any data to analyze. So the only option you left is you will collect all the salary data for whoever is working, and you will take an average of that, and you will say this is average salary. Okay, I will be able to provide this much because you don't have any data for you to analyze, data for you to check the relationship, data for you to apply some ML model. Okay, so the fundamental thing, if you don't have anything, is you will just go by average. Is it clear?
Yes.
Yeah, but now that is like zero case. Okay, but now since we have the data, okay, obviously we'll be having the data. How you are going to use ML, okay, to come up with the predictions, that we are going to see. So, but if we, since we have the data, so we are going to see the how linear regression is going to work. Okay, so now linear regression over here, if you see, actually let me uh, pick up some, I would say, linear regression image. Okay, just give me a second. Yes. Okay. So if you see here, yeah. So if you see here, this is X. Okay, this is Y. I have plotted. To plot 2D space, to plot any point in 2D space, you need two things. One is X, one is Y. Okay, and I have plotted all these are points. Now, see Karthik over here. Can you tell me, are these points are linear? I will tell you, I will define you linear. Linear means if all the lines are falling on a straight line, then that is called linear. Okay, can you tell me these points are linear?
No.
No, right? So the point is, for example, if you're having, okay, if you're having points this like this, okay, which are in the perfect straight line. Okay, fine. This is also linear regression because we want a linear relationship to exist between input and output. So we are having a perfect linear regression. In a perfect linear regression, what happens is you directly got a line. Okay, you don't need to actually perform any algorithm or ML. Okay, because every line, okay, so every point is actually falling on a exactly straight line. Okay, so you can just you have these data points. Once you have these data points, you can easily find the equation of this line. So you know what is the equation of the line. So you need to have a bit of calculus and line equation knowledge over here. Okay, so I hope you remember this from our school max. Okay, usually the equation of the line is y equal to mx plus b. Okay,
Yeah.
so there are different ways. So even if you know m and b also, you can directly plug in and you will have the equation. And what is m? M is slope over here. Okay, and b is what? B is y-intercept. Okay, so you might be knowing, but I will just give you a quick overview. Okay, so if you see here, yeah, over here, this this is x-axis, y-axis. Okay, this is some line. Okay, so or for example, yeah, you have this one. Okay, so yeah, over here, this is some line. The one it is touching over here. This length b is called y-intercept. Okay, the length on the y-axis is the y-intercept. Clear?
Okay.
Okay. Now this one. Okay, so let me take 1 second. This one from the x-axis, if you take the angle till this line, okay, that is a slope. Okay, one second, I will show you. See here, this one is b, this is y-intercept. Okay.
Yes.
Now from this this is x-axis. From this
Yes.
way, this angle till the line, whatever this, if you calculate this angle theta, that is a slope. Okay,
Yes.
tan theta is tan of that. This theta is equal to slope,
No.
right? This is slope. So
Yes.
like that, if you see, so just as an example, if I draw you, so yeah, so this is x-axis, y-axis. So if I just draw some line,
Mhm.
random line, okay. So this is touching over here.
Okay.
This length b, this will be equal to b, and wherever it
Mhm.
is touching the x-axis, thus this angle is theta. This will be the slope.
Okay.
Okay, so like that you can draw any line.
Okay.
Any line will have theta and m and b.
Okay.
For example, if I draw
Faster.
some line over
Yes.
here, okay, it is touching x-axis over here. This is the slope, and this is the y-intercept. If it is passing through the origin, then the b will be equal to
Zero.
0, and the slope will be whatever the angle you are having. Okay, is this clear?
Okay. Okay. Yes.
Okay, fine. So now I'm saying, if the data points are perfectly falling on a line, okay, then the equation is very, very simple. Okay, because you will have y equal to mx plus b, because every line you are able to capture the pattern. And yeah, since you have these different data points, from that you can calculate this m, and you can also calculate that b, and you can have this equation. That is simple, done. But you will not find this kind of data in real life. Why? Because real life data will have real life problems. Okay, so it is almost impossible to find a perfect data points falling on a perfect line. Okay, so it will be in this format. Okay, it will be in this format. Fine, so all these are data points. Okay, now you see, now the fundamental problem which we are trying to solve over here is, I'm saying these are my data points. Okay. Now, find me,
Yeah.
what does linear regression actually do here is, it will try to it will try to find out a line. Okay. First, it will try to find out a line which will pass through all of these data points. Now, can you tell me one line which can pass through all of these data points? Straight line. It should not be this. Okay. Usually
It's not possible.
you can think, okay, why not this? Why not this? This is perfectly falling, right? Okay. See, if you have,
Uh-huh.
see, we can have, see, obviously, if you draw this line, this is a stupid line, because it is not at all touching this one. Okay. But now I'm coming
Yes.
closer. Okay.
Okay.
This is not, we are not going to do this. But if you see, if I go through a perfect touching each and every point, it is 100% perfect. Okay. Why not, find out the equation of this particular line, because you are going to get 100% accuracy. Why not? The reason is, if you have this line, this is perfect. Okay, but the whole purpose of any machine learning algorithm is not mainly training, it is for the prediction. Why we are doing all this, whatever, even if you take the most advanced model, let's say ChatGPT also, they are training it for years on large data set, not for just training purpose, right? For the prediction purpose, for the users to use it. Agree? So for the user to use it, it should have a scope for prediction. But the problem with this line, if you perfectly do it, this will fall into a problem that is called as overfitting. Okay, this is overfitting problem. That means it has perfectly got fit into this particular data set. That means it is having no bias at all. Okay, there is a trade-off between bias and variance. If I remember correctly, we discussed sometime in the previous videos. Okay, so if not, you can let me know. I will discuss it again. Okay, so that means what? So if any algorithm is okay understanding the pattern of the input training data set so well, okay, then it will suffer or it will have trouble in understanding the pattern in the newly predicted or validation data set. Getting?
Sure. Yes.
Okay, that means what? I want my model to understand the input data, okay, decently, but not perfectly. I don't want 100%. Okay, it should not be 100%, because if it is understanding 100%, okay, it will be able to work only on this type of data, because I'm not training it for any new data, because I'm just saying, okay, the data will be exactly like this. Okay, it will just understand the only this type of pattern. Okay, the data one data point will be over here, one data point will over here. Okay, I'm fitting it so closely that it will not have any power to work on new data set. For example, the new data set is somewhere over here. It will not understand, because it did not understand the pattern. It did not take into account anything apart from these data points. Okay, but our goal is not for this training data points. Our goal is for newly coming or dynamic data or prediction data. Okay, to do that, to achieve that, we are not going to use this one. Okay, to save us from this problem of overfitting. Is that clear? Any doubts?
Yes, Santosh. No.
Okay, so now we understood that we are not going to do that also. That means we are not going to overfit. So now the point is, this is our data. Okay, how are we going to fit a line? Okay, now what do I mean by fit a line? That means I want ML algorithm to understand the pattern in simple words. Whether you do it by line or whether you do it by plane or whether you do it in your mind, I don't bother. Okay, but in this each algorithm has its own style, its own fashion, right? So in linear regression, it will try to do it by a line. Okay, so initially it will try to pass through all the data points, a straight line. Is it possible over here? No, it's not possible. So if it is not possible for a single straight line, what is the next option, man? If it is not possible to pass through all the data points, the next possible option is
To
pass
nearest.
nearest. Yeah, pass through as much closer as possible. Okay, if you're not able
Yes.
to do justice to all the data points, at least do justice to maximum number of data points.
Q. Yes.
Agree? That's the only option we have left, right? I cannot pass through all the points. At least I
Yes.
will try to pass through or be as closer as possible to maximum number of data points. Cool.
Yes. Yes.
So that is the reason. This is the way. This will be the way most of the time you will find the real data. And from here we want to find out this line, okay, such that it will be closer. Okay, but still we are talking in theoretical, okay, words. But now slowly we will see technically what does it mean and how does Max will help us, okay, to give us this line. Okay, so now after that, just give me a second. Yeah. So now over here, if you see, in our simple linear regression algorithm example, if you take, so you are having CGPA, you are going to predict salary. Okay. Now the equation of the
Yes.
line will become what, man? It will become y equal to mx plus b. Agree? Now what is
Yes.
y? Y is
Yes.
salary.
Yes.
Salary equal to m times, okay, m times my x. X is what? My CGPA, some score, plus some b. This is my line. Okay, that means whatever the input
Correct.
CGPA you are, if you know the value of M and B, assuming you know value of M and B, if you just give me a new person, okay, or fresher or some experienced guy CGPA, okay, assuming for let's say this M is 5 and this is 2, okay, new person CGPA, he came and he said his CGPA is some 8.4, just multiply this plus 2, that should be the salary. Okay,
Yes.
have this equation. But now, what problems are we facing over here to find out this, and what we are trying to achieve fundamentally, that we'll try to see. And also, you need to understand over here, it's the only game with M and B. It's just the game we are playing with these two M and B. We are going to see. Now, what does this mean? You are saying the salary. Always try to understand equation in words. This I'm saying when I write this, this means that salary equal to M times CGPA plus B. That means the input is only CGPA, but my salary is dependent M times my CGPA. That means if M is more, okay, that means
Salary.
you are multiplying more value with CGPA and your salary is increasing. Fine.
Yes.
So that is the relationship you are going to have. That's fine. But why B over here? What is this B doing? Fine. That I'll give you a small example. So this is actually called offset. Okay, that means nothing. It's just a default value. But why default value? Because even if you don't have any value over here, still you should have some value. Because, for example, if you say, as a basic example, if you're having, let's say, experience salary, this is your simple use case you are trying to solve. Now, if you put this same thing over here, what will be your equation? Salary equal to M times
Past experience.
M times experience plus B. Agree?
Mm. Yes.
Now, if you whatever the experience you put, you multiply and you give. But let's say a fresher has and came for the interview. Okay, his
Correct.
experience
Correct.
will be zero.
Zero.
Now,
Though he will get the jobs based on some salary.
correct. So if you don't use this B, that means salary equal to zero. So you should not give salary to freshers. That doesn't make sense, right?
Yes.
So you should have some
Yes.
offset value. That is B, some default value. Okay, even though you don't have any input, still there should be some output. Is it clear?
Yes.
Okay, cool. So now that is why we are having this okay, B. So after that, you are going to see fundamentally now the equation of the line has become y equal to mx plus b. Okay, so this is the basic equation of line. Okay, but using this, how are we going to, okay, apply to our linear regression concept, and we will try to achieve what we want to find. But now what we are actually trying to find, that we will try to visit once. Okay, so if you see here, let me use the same algorithm, same okay, so I will use the same image again. Okay, so just give me a second. Yeah, so see here, this is actually the main thing which we are trying to achieve. Mainly what we are trying to do here is simple. Given these data points, I want to find out this line, and this line, okay, there could be many lines, right, Karthik? Forget about this line. Okay, here this guy is already saying this is a regression line, but forget about this regression line. But just given these data points, you can draw any line. Okay, first of all, I will try to draw something like this. I can draw something like this. I can draw something like this. I can draw something like this. So many lines are possible, right?
Yes.
Agree? There are so many lines possible. But there will be, among all this unlimited number of lines, there will be only one line, okay, which will be the best line. That's called best fit line. Okay, that's called best fit line. Getting? But how it is called and why it is called best fit line, on basis of what it is called best fit line, we are going to see. Cool. So now, if you see, firstly, you are going to do few things. So one is the best fit line which you are trying to find over here. Okay, the best, this word you should remember, okay, from now on, because this is one of the key word. If whenever you're studying the linear regression, right, so obviously you will be encountering this word a lot. Best fit line. Okay. So in interview, for example, someone asks you, just tell me what is the aim of linear regression in one line. It's just to find the best fit line. That's it. Okay. But after
Okay.
that, what is best fit line? It is a line, okay, which will have the minimum distance from maximum number of points. Okay. So you can use your
Okay.
own definitions. Okay. If you know the concept. Fine. So it is just you're getting right. What is the best fit line? It will try to, pass through as closer as possible to the maximum number of data points.
Yes.
Okay, fine. So now to find out this best fit line, actually, over here in this concept of linear regression, you have two main methods. Okay, so one is called as OLS. It's called ordinary least square. Okay,
Okay. Okay.
ordinary least square. And second thing is GD. That means gradient
Gradient.
descent. Okay, gradient descent. Okay, so now these two are very, very important methods, and the one which you're seeing on the left side is ordinary least square. Okay, when you I'll show you the example also, but this is when you run it in the notebook. Okay, you have this library called as sklearn, scikit-learn. Okay, that is the ML library from Python, which has all the related libraries and modules that is required for, okay, pre-processing, right from pre-processing and models, everything end to end. When you try to implement linear regression using scikit-learn, it internally uses this method, not this method. Okay, but
Okay.
these are two methods which will achieve the same thing. Okay, so it's your wish which one to use. We will see the both, but mainly if you see, by default when you run the scikit-learn, it uses this method, OLS, ordinary least square. There is separate library called as SGD regressor, stochastic gradient descent regressor. It's a separate library. If you specifically call that, then it will use gradient descent. Okay, so but what is the difference, and why are there two methods, and which is the best? If one is already best, then why we should go for the other? You might be having some questions. Okay, I'll just give you an overview. Ordinary least square is simple method. Actually, it's a basic normal algebra calculations. If you know, that is enough. Okay, and whenever you're studying, right, so it's best to first study by ordinary least square. Okay, but if you it is very simple. But now when something so simple is available, why we should learn this? The reason is this is simple, but you cannot implement it. Okay, like you cannot, it's a bit becomes a bit complex when the order is higher for multiple linear regression, or but for higher polynomial order regression, right? So it becomes difficult. I'm not saying it's impossible. It is just an extension of the same calculation, but the calculations become much lengthy. I will show you the calculation, then you'll understand. Okay, but still, if you want to do, you can also do with this. But for higher, or but more, I would say, efficient way, I would say, is a gradient descent. Okay, because this uses calculus concepts. Okay, and it is a bit more interesting, I would say, and more mathematically backed approach. Fine, and it is also having different types of gradient descents inside it. Okay, so which we are also going to see. But remember, Karthik, this gradient descent concept is very, very important, because the whole deep learning is dependent on this gradient descent. You know,
Okay.
the fundamental of the deep learning, or whatever the models which we are trying to learn, right? Even as a fact, I can tell you the latest model, whatever the GPT or the chat GPT, whatever we are using, right? The latest model, LLM models, every model internally, it should go through a training process, right? Only then it will give you predictions, whatever the answers it is. During the training process, the way how it learns is through this concept called as gradient descent. Okay,
Okay.
so this is a fundamental concept for you to learn. If you learn it in here in linear regression, then it becomes a fundamental concept for you over in the deep learning also. Okay, so we will
Okay.
be seeing this mostly in the next class. Now coming, let's try to understand this ordinary least square. But again, just don't forget that the aim of both of these methods is to give us the best fit line.
To
The
get
best fit line
that's
is the
yes.
line which will try to do maximum justice to the given data points. Clear?
Oh,
Huh?
yes.
Any doubts?
No.
Okay, fine. So now if you see, we'll try to actually dive into the main thing what we are trying to uh, achieve in this class. So over here, if you see, this is my data point. Okay. Now just forget about this regression line. I don't know what is this line. Just some random line. You can draw this line. You can use this line. Any example you can take. But this some line is already there. I'm considering this. Okay. Now I have drawn this line. This is my first data point. Okay. What is this? This is my x1 y1. This will be my x1 y1. This will be x2 y2 like that. There are endpoints. Now if you see, this is my some line I'm saying. Okay, some line. Now when I say this is some line, that means I am saying this line equation will be y equal to mx plus b. Obviously any line equation. Fine. That means what? When I say this line will be the prediction line, which means that any new input I am giving, I am going to calculate the prediction from this equation line. Try to understand that. I said the whole point of finding this line is for what? First we will train it. After that we are going to do some predictions. Clear?
Yes.
So now I am saying, okay, by some method, I found out this line. Now I am drawing this line. Okay. So now this line, when I am drawing this, so that means what? I got this some equation of this line. Once I get the equation of this line, I am going to use it for all my further predictions. That means what? Let's say this line equation is m equal to 2 and b equal to 3. So my equation of the line has become now y equal to 2x plus 3. Now, whoever gives me the value of x, I am going to give him the value of y. Got it?
Correct.
Simple.
Yes.
So now, if you change the value of m and b, or even if you change the value of m, you will get a new line. If you change the value of b, you will get a new line. Okay. And now
Correct.
if you try to understand, those are the only two ways how you can alter this line. That means what? There is some line. Okay. Like this. Now, what is m? What is m? M is just slope. Slope means what? Angle. This angle. You can see this angle.
Changes. Yes.
Okay. B is not changing. That means y-intercept is not changing. Y-intercept is fixed. Only the angle from x-axis is changing. Can you see this? Only angle
Yes.
is changing. Okay.
Yes.
So for every m you change, see this is m1, m2 because angle is changing. Okay, m3, m4. You are getting a new line.
Correct.
Similarly, let's say now I'm fixing m. Okay, I'm not changing the angle. Okay, only b I'm changing. That means I'm just moving up and down. But the
Correct.
angle with x-axis is same. Okay,
Fixed. Yes.
angle with x-axis is fixed. Only my b-intercept is changing.
The interpretation. Yes.
Still that will be a new line every time.
Correct.
Okay. Now changing m also will give you new line. Changing b also will give you new line, and changing both also obviously will give you new line. Okay.
Correct.
Now for one single line, you are going to have a set of unique some m and b combination of values. Like that,
Hmm.
you can come up with some unlimited number of m and b. Okay. Even if you
Yes.
slightly change, instead of 2, I will say 2.2. That will be a new line.
Correct.
Agree? Over here, instead of 2, 2.2. Instead of 3, 3.01. You can have unlimited, innumerable number of lines. Our goal is from that, we are going to find out the best fit line. That is a job.
Oh, okay.
Clear till this point?
Yes.
Okay, fine. So now let's jump into the actual details. Okay, focus here. This is the actual max you need to understand. Just to understand these small max and equations, done. Okay, OLS is nothing. So now if you see here, Karthik, we are having these data points. Now, this is my line, some line. I'm not saying this is my best fit line. We'll start with the idea is start with some random line. From there, understand the max. okay, equations, and that will automatically will give you the best fit line. Okay, so
Okay. Okay.
this is some line already there. Okay, so now this data point is actually over here. Okay, that means what? This is my y-axis, this is my x-axis. Okay, so but this line is saying this. When line is over here, okay, so that means what? Observe here carefully. That means this is, let's say, x1 y1. That means what? See, if I just draw a projection over here, and if I just draw a projection over here, okay, this length, this x-axis length is x1. You agree?
Hmm. Yes.
That is the concept of this coordinates, right? And this y-axis length, forget about this line. Initial, just you have plotted this point, and this is x1, and this is y1.
Y1.
Agree? Now,
Yes.
now what is happening? You are bringing this line. I'm saying, okay, this could be best fit line. I'm saying, okay, just some random
Hmm.
line. Now, if I am saying that this is the line, then every prediction I should take it from that line. Okay,
Correct.
sorry. Okay, so now if I say this for this point, the projection of we should, as per this line, okay, as per this line, what will be the value of this point? Okay, the value of this point will be, if you draw a projection, wherever it is falling, okay, wherever it is falling, fine, that will be the y as predicted by this line.
Okay.
Okay, see, try to understand it again. These are the actual x1 y1 are for the actual coordinates from the raw input data set.
Yes.
But now
Yes.
if you are using some line, now if you ask this line, hey, I'm having this x1, as per you, according to you, what will be my output value?
Prediction. Y. Yes.
Okay, so now as of now we
Hmm.
don't know this, 2 and 3. Okay, we don't know, we just know this y equal to mx plus b only. That is the equation of the line. Okay, so now if you just tell him that, okay, my value is x1, so it will tell you the output value will be y equal to m x1 plus b.
Correct.
Okay, now where will you find this value y equal to m x1 plus b? On this line only.
Correct. Correct.
Okay, because when I'm saying this line, that x and y should be present on that line. Okay, so the projection, whatever you are using, so whenever you project this, right, so this one, okay, now that one will be y1 hat prediction from this line.
Okay.
Okay,
Okay.
so that means, but x1 will be the same. Okay, because over here this data point will be, observe here, this data point will be x1 comma y1 hat.
Okay.
Okay, getting?
Yes.
The actual data point is x1 y1, but the prediction from the line will be over here. How will you get the prediction? Just project the
Correct.
data point wherever it is falling. That point will be the prediction. So over here, this value, if you see, the x distance is same from the y-axis. The distance is same. How much this is the same, because you are directly projecting that point on the line. This will be same, x1 only. But y distance, if you see, that has decreased. Agree?
Correct.
Actually, the actual point is this much. That means what? Actually,
Hmm.
this much. That is y1. But that is the actual value. But as per the line, the prediction is this, wherever it is
Correct.
falling on the line. So that is only this much.
Yes.
Okay. And that will be called as y1
Yes.
hat.
Okay. Okay.
Okay. So the actual value is x1, y1. This is y1 hat. Okay. And what happened to this distance? This distance, let me call it as d1.
Okay.
Getting? And that distance is the
Hmm.
error. Why
Yes.
error? Because the actual value is this, but the prediction is this. There is some error.
Correct.
Getting? And for this
Yes.
also there will be this. This is the error d2.
Projection on the top. Yes. D2.
d3. All these are error. For
Yes.
example, just as an
Yes.
example, you are having some line which is which some point falling exactly on the line. For this, what will be the error?
0.
0. Because it is the x1 y1 is also over
On the
here.
line.
X1 y1 hat is also on the line. So error will be 0.
Yes. Yes.
Okay. And for this, there will be some error, some d. Agree?
Yes.
So now, if you see, the error is, okay. So now if you start writing the equation, the overall error is nothing but d1 plus d2, okay,
D2.
so on dn.
Correct.
Okay, all these errors is the error. Now,
Hmm.
if you simply think, one logic over here is, if all this, if this is completely equal to zero, if I say, what does that mean, Karthik? Can you tell me?
All points are on the line.
Perfect. Okay, which means that
Hmm.
this example which I was telling, right? This example you will get.
Correct.
Correct?
Correct.
That means there is no error.
Hmm.
All the line is able to perfectly pass through all the data points. Okay. But that
Correct.
will not be the
Hmm.
most of the case. You are always going to have
Yes.
some error.
Yes.
Okay. So now our error is D1, D2, D3. But now our aim is in mathematical form, words, if you say, our aim is to find out a line. Okay. To find out a line which can give you minimum error. That means what?
Yes.
See, I'll just extend, you can just extend this thought. Okay. You are saying this line. Okay. This is your Karthik line. You are getting this one. Now, if I say, hey, I don't want this line, just as an example, I will draw some other line. I will say this line. Okay. With this also, if you just project, I'll have some distances. Okay. I'll call it as line 2 D1. Okay. And with this line 2 D2. Okay. I can calculate errors again, distances for this line.
Correct.
Same like
Same.
how you have done this one,
Another line with the
same thing
different.
I will do.
Yes.
And that I will call it, this
Yes.
is for, if I call it as for line one, I'll call it
D1.
line two. I'll again
D2.
calculate D1, D2, D3. I'll have set. Like that, you can do it for how many lines?
Infinite number of
Infinite
lines.
number of lines. Okay. And from that, you are going to get one line which is going to have this error minimum. That is the goal.
Yes.
Agree?
Yes.
Okay.
Yes.
So we are going to just take one line as an example, and from there we will try to derive the equation. Clear? On track?
Okay. Yes.
Okay. So now there could be any number of lines, but this is, let's say I'm taking one line. Okay. So any line. So this is a distances. And now our aim is simple. Find me that line which can give you minimum of this error. That means what? No other line. If you are telling, okay, when I'm saying best fit line, so when I said this best fit line, what does that mean? This is the line which can give you the minimum error. That means no other line can give you less error than what this best fit line is going to give you. If some other line is going to give you less error than that, then that line will become the best fit line, not this line. Getting?
Correct. Correct.
Agree?
Yes.
Right. So now over here, there is this is a equation. So just one single thing you need to understand over here is d1 plus, instead of doing d1 plus d2 plus dn, we will actually do d1 square plus d2 square till dn square. Why? It is very simple, because over here, if you see, some data points are above the line, some data points are below the line. Okay. So if you directly do this one, what happens is, let's say this distance is 10. Okay. Now, but this distance is exactly 10, but it will be minus 10. If you add, what will become? It will become 0. That means it is incorrectly saying that there is no error at all.
Correct.
Getting? But actually there is error is 20, not 0. The reason is because you are
Yes.
using this sign, you are getting. So to deal with that, we are going to use this square. Clear?
Okay.
But now you
Okay.
can ask,
Yeah.
why only square? You can use mod also, because mod 10, mod 10 equal to 10,
Hmm.
mod of minus 10 is equal to also 10. Do you know this mod sign? There is modular. Okay.
Yes. Yes.
Mod of
Yes. Hmm.
positive or negative is also 10. Okay. So
Yes.
we can use this also. So, but the reason over here is, there is something called as, we want to penalize data points with higher error. That means what? In simple terms, if you use square, okay, if you use square, what happens is, the data points with error will increase their error more, so that our line will try to ignore those and will try to, do justice to nearby data points. See, what I'm trying to say over here is, let's say you are having a, sorry, let's say you are having a uh, data point whose error is 7. Okay. So above it
Okay.
is having 10. Okay. If this is a line, if you are having 10, that will become what? 100. 10,
100.
100. Okay. Now, let's say if you are doing mod, okay, if you're doing mod, okay, below you are having -7, above you are having 10. Now, say if you're using this mod, how much this will become? 10 will
10.
become 10, 7 will become -7 will become 7.
7.
Okay. So if you add, it will become 17. Okay. It will become
Hmm.
17. But if you see the distances are not small, we are having good distances, 10 and 7. But if you're just doing the mod, you are taking the actual values. That means what? You are telling the line to do justice to these points also. But our concept is do justice to the nearby maximum number of points. That means if the lines are too far off, I mean, if the data points are too far off, instead of trying to do justice to them also, whatever the data points which are nearby, we'll try to pass through them in the maximum possible way. You can achieve
Okay.
that by like this. For example, if you're doing for 10, if you do square, you will
It is
get 100.
100.
For 7, you will get 49. That means if there is an error, you are increasing it more, you are squaring it. That means now it will see these data points are having much error. So instead of doing justice to them, the line will adjust itself so that it will pass through data points which will have less error. For example, if you're having like
Okay.
and 2, the square of 1 will be 1 and the square of 2 is 4. Okay.
Hmm.
Instead of going, okay, to do justice or pass through this data point, okay, which is not worthy because they're having much error, it will just pass through these data points. Because if you consider this, the error will be less, but if you consider this, the error is more, and our goal is error should be less.
Okay.
Getting? But if you consider in the mode,
Yeah.
if you use mode 1 and 2, okay, if you use mode 1 and 2, it will be again 1 and 2 only. Okay. Over here,
Correct.
that is fine. That means if it is smaller value, the square will be small. But if it's a larger value, the square will be larger. That means we don't want to consider data points which are giving us larger error points. Okay, because
Okay.
our whole goal is to have the minimum error. Okay, the
Correct. Yes.
complete agenda for linear regression, what only one thing will be present in its mind, that is give less error. That's it. Only based upon that goal, it will try to do progress and finally achieve the best fit line. Okay. Whatever you do, just give the line which is having the less error. Less error is the main heart of this problem, I would say. Okay. So let's come back. So now we understood that simple. You're on track, right?
Yes.
Yeah. So just we have the data point. We found some line, and from that we are having these distances d1, d2, d3, dn. That's it. And after that we are squaring it. Okay. So why we are squaring also we understood. Okay. So now if you see our error is finally we can write our error is nothing but I will write it in simple form I equal to 1 to n d I
N.
square.
Okay.
Okay. Summation. That means just from d I you will replace this I 1 to n. So d1 square d whatever you are going to get, you will just expand, you will get that summation notation. Okay.
Okay.
Now if you see our line, okay, our line, whatever the line we are using, right? So y equal to mx plus b, okay, y equal to mx plus b. This line should give us the minimum error. Okay,
Correct.
this line should give us a minimum error. So that means what? Our error function is dependent on two things, m and b. Why? Because as I said, if you change m also, you will get a new line, and that will have an impact on error. If you change b also, that will every time you change b also, that will create new line, and every new line will have different types of distances. And if you add all those, you will get a different new value of e. Okay.
Yes.
That means your error is dependent on two things fundamentally, m and b. Okay. So
Correct.
the error equation is dependent on two things, m and b. Is this clear?
Yes. Clear.
Right. So now we'll talk a bit max over here. So whenever you are having a function, okay. Now my mathematical what I told, find out the values of m and b such that you will get a minimum value of e. Okay. But here you should understand clearly. Many people will think that you should find out the minimum values of m and b. No. Okay. Usually people
No.
get
No.
confused. I don't
You
want
should.
minimum
Yeah. You
values
should
of
be there.
m and b. I want those values of m
E
and
should be minimum.
you minimum E.
Yes.
Okay. Whatever those values of m and b,
Yes.
I don't care. M and b could be 0, 1, 10, 20, -100, whatever. I don't want to know what are the values of m and b I'm going to get. But that set of values of m and b should give me minimum value of E. I'm only concerned about, I'm only looking at E. Okay. This should be minimum.
Correct.
Okay. This should be, this sometimes in interviews people might get confused. Okay. So always remember, we are not focusing on the minimum values of m and b. We are just focusing on the values of m and b that will give us
Minimum
the
value.
minimum value of E.
Error. E.
Okay. Fine. So
Okay.
now what we are going to have. So over here, yeah, let me take it this way. So you are going to have E equal to, let me write this again. Okay. So you are going to have E equal to summation of I equal to 1 by n di square. Now, what is this di distance? Okay. What is the distance? Distance is this distance.
From line to point. Yeah.
Yeah. So I mean this distance. Now, how we get
Correct.
this distance? This overall distance is y1. Okay. For this point, if
Yes.
you see,
Yes.
this overall, this one is y1, yi. Okay, yi, not y1, yi. The actual given xi, yi.
Hmm.
Okay.
Hmm.
And from wherever it is pointing the line, that will become yi hat.
Y
Okay.
cap.
Yi hat.
Y1. Yeah. Yeah. One. Yeah.
Okay. Now, if this total is yi and this is yi hat, what will be this one? The error. What will be the error?
Yi minus yi hat.
Correct. Okay. So, but the distance, whatever you are seeing over here is the d will be equal to, I will write here. Okay. So over here,
Yeah.
okay, let me 1 second. So over here, so now this will be interesting. You see the equations. So E equal to nothing but summation I equal to, okay, 1 to n d I square. But over here, di is
Correct.
nothing but yi minus
Minus
yi hat.
y1 hat.
Okay, yi minus yi hat. Okay, so you try to
Correct.
relate with the actual diagrams. Okay, di is a error or the distance for one single point. And what is single point
Yes.
in normal words also? What is error? Actual value minus predicted value. Agree?
Correct.
Even in normal language also. So if you calculate something, but the actual ground value is something, but calculated value is something else, that is error. Here also this is
Correct.
actual value. Y is actual value. This is a predicted value from the line. The difference is the
Good.
error. Okay. So now
Okay.
that is a di. If you do it for all the data points, you will get the overall E. So if I try to replace
Yes.
it over here, I'm going to get, I'm not writing this summation every time. Okay. So, but just
Hmm.
understand summation is there. So I'm just saying now E will be di square. That means what? Yi minus
Minus
yi hat.
y square.
Clear? But now if you
Yes.
see here, what is this yi hat?
Predicted value.
Correct. But what, from where you are going to get this yi hat? Who is giving you
From
prediction? From where you are getting the
um,
prediction?
from line.
From line, right? Now, what is the equation of the line?
Yes. Y equal to mx plus c.
Correct. So now what will be the equation of this line when I'm saying when y is yi hat? So the equation will be yi hat equal to m
Oh,
xi
okay. M.
plus
Yes.
b.
Xi plus b.
That is the equation. Because if you see here,
Correct.
how you are pointing over here. So I'm saying, hey line, I am passing you xi. Give me the value of
Give
yi.
me y
So
hat.
what it
Yes.
will do, it is just having this equation. This line is just having this equation y equal to mx plus b. So if you
Yes.
whatever x you give, it will give you corresponding. It will put it over there. So how did you get this y hat? I got this y hat is from this equation by putting this xi. So this will become m
Correct.
xi plus b.
Plus b.
That will be my y hat.
Yes.
Okay. For same thing for
Okay.
this, it will be y2 hat. Okay. Y2 hat will
Hmm.
be
Some form.
m2 plus b.
M to x. Yes.
Okay, because this data point will be x2 y2, just as an example.
Mx. Yeah. Mx. 2 and plus b. Yeah.
Okay, clear?
Hmm.
Okay, so now if you see here, distance is actual minus predicted. That's fine. I replace this. But now here this actual value is yi, but the predicted value is yi hat. But this prediction is coming
Yes.
from a line. I'm just taking this as
Yes.
an example line. I have this line. I don't know what is the values of m and b, but that's fine. I know the equation of the line. That is mxi plus b. Okay.
Correct.
So now what I will do, I'll just replace this e equal to
yi minus
yi minus
half
mxi
xi
minus.
minus b whole square. Yeah.
Okay. Now this is the error. But if you see here, what is yi
yi is for
output?
first point prediction. Yeah,
Uh,
output. Yes.
no, no, not the first
Yeah,
point.
yeah.
I'm saying y1, yi,
Some,
general,
yes.
some
Yeah,
data.
yeah, yeah, yeah.
Yeah, the input yi. Okay. Xi is
Hmm.
input x. So these are the input values.
Correct. Input values.
You have it in your data
Actual,
set. Okay.
actual values. Actual values.
Yeah. Actual values, x and y, whatever you're having, right? The same thing, x
Correct.
and y from where you are getting from the input data set.
That point from input data set.
Correct.
Yes.
Okay. So you know this yi, you know this xi. You don't know m and b.
Hmm. Correct.
Okay. So now obviously you should have the summation over here. Okay. So now
Hmm. Hmm.
if you can replace this xi. So that means what? Take first xi, take first data point. Let's say
First point.
xi, yi. Replace xi,
Yes.
yi. You don't know. Okay. See, for example, as a simplicity, you are
I
having
1 comma 2, 2 comma 2. Yeah.
yeah,
Yeah.
some no m I'm taking it as some 2 and b I'm taking it as 3. Okay, this is m and b. Okay,
Okay.
so with that you will have
Okay.
one
Okay.
equation line, and with that equation line,
Correct.
okay, with that equation line, replace all the values of x and b. Okay, let's say you are having okay, you are having this, for example, just as an example, yeah. So see, you are having the CGPA package. Okay, this is the first data point. Okay, 6.8 and 3.26. Okay, some value. Okay, so you replace that. This y will be how much? Y will be 3.26. This is y. Package is y.
Perfect.
CGPA is
Yes.
x.
Yes.
Okay, so this
Yes.
is 3.26 and this is
6.8.
6.89.
6.8. Okay. Yeah.
Okay, and you put it over here. And m and b, some you will have some value 2 and 3. Okay,
Okay.
and after that, this is summation, right? So summation means what? You need to
Correct.
add each and every value.
You need to give the
So
every
put
value
it everything.
on the
You will
same
get some
20.
value.
Yes.
You will get some value.
Correct.
Okay, you will get some value. So like that, if you do, you will get this error for this line, some random line. Like that, if you change these values, again, you are going to get different values. Okay, this is an example I
New
told.
line. Yeah.
Okay, so but
Yeah.
now I don't know what is this m and b values. I just have this equation. Okay, from this equation only, okay, from this equation only, I want to find out the values of m and b such that it will give you the minimum e. Okay, is the goal clear?
Correct. Correct.
Okay,
Yes. Clear.
now if you see, we can easily find this. Okay, but before that, let's try to understand what happens. Okay, I'll just tell you what happens with the effect of this m and b, okay, on the error. So for example, if you see, uh, just as an example, okay, there are some, okay, let's say this is some data points. Okay, and over here let's consider individual m and b. Okay, first I'm taking, this is my error value. Okay, this is my m value, this is my data point. Now some random line I'm taking. Okay, some random line I'm taking. Okay, it will have some m I'm taking. Okay, so
Yes.
what will be the error? The error will be high or low for this line with this data points?
Right.
High. Why? It is not passing through any point at all and it is far away.
One of the point.
Okay,
Yes.
so my initially, if I take some value of m, okay, so the error is high. Now let's say I am coming some closer. Okay, my error, this is error, y-axis is error. Okay, so my error is decreasing. Okay, now again, if
Hmm.
I come closer, my error might decrease. If I if I pass through almost sort of in the middle. Okay.
Hmm.
Now, if I again change the, oh, sorry, I'm changing the M, right? Okay. I'm changing the M. So this is actually M means what? Intercept. Okay. So let's say it is just some, okay, my Y intercept is fixed. Okay. My B is fixed. That means what? Let's say some random line I'm taking. Okay. This is uh, some random line. Okay. So this is
So,
having this
uh,
Y intercept. Okay.
yeah.
I will just
From
fix
the
this.
same,
I'll just fix this.
yeah,
Okay. That means this is the line. I'll just change
correct.
N.
Just we need to
That means what?
we need to change the angle. Yeah.
Angle. Only this will be angle. Okay. It is passing the same data point. You see. That means Y intercept will be same.
Yes.
Okay. So initially for this line, the error might be more. Now, if you come closer, the error might be less. Okay. Again, if you go through, error might be less. Okay. Again, if you pass again, the error might again slowly start increasing. Agree? Because you are missing the points again.
Correct.
Again, if you go here, the error is again increasing. Okay. Again, if you go here, the error might be increasing. Fine.
Yes.
Okay. So you are finding like error is decreasing, increasing. Okay. You can find like this also. Like again, it might increase, decrease. You can find this way also. Okay.
Okay.
But just we are understanding before driving into the actual details. What is the effect of M? Okay. That means see all this we are just beating around the bush. That means what we are just throwing stones in the dark. We don't know. Okay. I'm just drawing to these data points, but in actual scenario, okay, we don't know where the line is going to start. I don't know what are the values of M.
Correct.
Okay. Randomly, if I take M and B, that could be the best values or that could be the worst values also. Okay. Somewhere
Correct.
the line might start from somewhere very far from the data points. I don't know. Okay. That's what. So, but gradually, if you are changing the values of B, keeping the values of M, keeping the B fixed, there is a possibility that slowly at some point of time, it will come closer to this actual data point so that the error will slowly decreasing. Again, the error will be
Agree.
if you keep on changing the values. Clear?
Yes.
Same thing if you see with the B also. Okay. So that means what?
M is fixed.
Yeah. So if you see with B also, what happens? So some random value I'm taking. Okay. Now here this is some B. Again the error is okay. Let's say this is now B. Now I'm fixing M. That means what? The slope is fixed. That means see all these lines, parallel lines will have equal slopes. Okay, that is a rule. Agree? Parallel lines will have equal.
Agree.
That means this one,
Yes.
this one, this one, this one.
Yes. Yes.
All this will have same slopes. Okay. So here also, if you see initially over here for this line, the error might be more, and slowly if it is coming closer, the error will decrease. Okay. And again, if you're going far away, the error might increase.
Yes.
Okay. So this is a
Yes.
relationship this M and B is having with what? With my error.
Points. Data point.
With my error.
Yeah. Correct.
Okay. So now what we'll try to do here is now we will try to actually frame the equations. Okay. So that should be the our goal. So, but if you see one interesting fact, I will tell you, see, Karthik, I'm having a equation of the line. Okay. So I'm having an equation of a line. So over there, for any equation of the line, my E is my error equation. My goal is to find out the
Yes.
minimum value of that. Okay.
Yes.
In max, we have a rule that in sorry, not max in calculus, minimum value of a function will be found where its slope will be zero. Okay.
Correct.
That
Hmm.
means, for example, if you have a graph over here, okay, if this is a graph, you take any value. What is the minimum value? This is the minimum value.
Yes.
Okay. But how will you find out? You can say that by the slope will be zero. Why it
Yes.
is zero? Because if you draw a line that will be parallel to x-axis, any line parallel to
Correct.
x-axis will have
Slope is zero.
slope will be zero because there is no angle with the zero angle with the x-axis. Okay,
Yes.
so over here you have a yeah. So if you see here where you can find the minimum value of a function will be where you have the, when you equate it to 0, right? So when you equate it to 0, you will have the minimum value. Okay, so you can just Google it. Okay, it's a calculus fact. Fine. So usually a function's minimum value can be found where the slope is equal to 0. Now, interestingly, how you are connecting these concepts, you see. So I'm having this equation of this function. Okay, what is my equation finally? This is my equation. Okay, and I want to find out the minimum value. Okay,
Yes.
that means what? That means
N is equal to 0.
wherever the slope is equal to 0, that is a place where I'm going to get the minimum value. But now it is not dependent on one variable. It is dependent on two variables. What are those two variables? We are having m and b.
Yes.
Okay. So in this scenario, we need to do something called as, and before that, how you are going to do get the slope when you do the differentiation. Okay, in calculus, what is
Okay.
slope? It's a differentiation. Here also, when you do this slope y equal to mx plus c, what is m? M equal to nothing but y2 minus, there are different values how you can find out m. So y2 minus y1 by x2 minus x1. What are the any two data points you take, when you do y2 minus y1 by x2 minus x1, it will give you the slope. Or if you don't want to do this, in simple words, m is nothing but tan theta. Okay, whatever the theta you are
Yes.
having, this right? If you do tan of that, that is the slope.
Yes.
Okay, and tan theta, when you do what is tan theta? Tan theta is called sin theta by cos theta. When
Correct.
you're doing tan theta, this is called differentiation. Okay,
Okay.
when you are calculating slope, one way to do is do by the differentiation. When you differentiate a function and equate it to 0, okay, that means you are calculating the slope.
Okay.
Okay, so that is a fact. Okay, from the calculus, you can just Google it and let me know if you're having any doubts. Okay, but going back, now if you see, I'm just erasing this. Okay, are you following, man?
Yes.
No doubts, right?
Hmm.
Okay, so now simple. Okay, so just give you 1 minute, so 1 second recap. So we have this line. Okay, we have this error. From this error, we have this distance, and from that you replaced, and finally you got this. Now our single line agenda is to find out the minimum value of this error, and this is an equation which is
Correct.
dependent on two things, m and b. Okay, so if
B.
it is dependent, let's say only on m, we will just directly do differentiation with respect to m, and you will equate to 0, and you will get the value. Same thing, if it
Correct.
dependent only on b, you will do the same thing and you will get the value. But now here it is dependent on two things. One is m and one is,
Yeah. B.
here you need to do something called as partial derivative. That means initially you need to do only differentiation with m. While you are doing m, you need to consider
Then
b as constant. After that,
yes.
you need to do differentiation with b,
Do
and
with
when you're
B.
doing that, you need to
Then
consider m as constant.
answer.
Okay. So once you do that, you are going to get these two values, and using those you can actually get the values, and it is also not that hard. Okay, so now if I just quickly show you. Okay, so just give me a second. Yeah, so over here, if you see, I'm having this e values, right? So yeah, so over here, if you see, what is my e value is this. So initially, let's do dou e by, it's called dou, man. Okay, so when you're doing
Yeah.
partial
Yeah.
derivative, it's called dou.
Very good. Yeah.
Usually you will have d by, okay, but if you're doing partial, it's called dou. Okay, dou e by dou b. I am doing
Okay.
differentiation with respect to b. That means m will be
B.
considered as a constant. So whenever you are doing differentiation of this function, initially you should do overall differentiation, then individual inside terms
In
differentiation.
individual.
Okay, so
Yes.
when you're doing dou e by dou b, that means first overall differentiation will be, first you should do power. Okay, so any function to the power x, differentiation will be, first you should bring this x down and function of x minus 1. Okay, then internal, if you should do differentiation, simple. Okay, that
Yeah.
means what?
Yeah.
First you should bring this 2 down. Okay, I'm not writing this one.
Mhm. That's
Okay,
important. Yeah.
but finally we'll write. Okay, so dou e by dou b means just bring this 2 down. 2 you will have over here. Then write
So
everything yi minus mxi
MX
minus b.
minus B.
Now internally you need to do
Into
differentiation. This yi is constant.
yeah.
That means one data point. A constant differentiation is
Yeah.
0.
Yeah.
Okay. and m is constant. X is also constant. This is also 0. Differentiation of b with respect to b I am doing 1. Okay.
1.
Differentiation of anything with respect to it itself will be 1. Okay. Minus 1. Clear?
Yeah, clear.
Now it will be 0, 0, minus 1. This will be minus 2. Okay. And this should be equal to
Minus
0.
0.
Okay. Error is not equal to 0. This is just a error function. Okay. But when you're doing partial differentiation,
Yeah,
this should be equal to 0. Okay. Now 0, 0,
yeah.
minus 1. Okay. Now this will become minus 2 into yi minus
Mxi minus b
minus b equal to
equal to 0.
0. Okay. Clear?
Yeah, clear. Y equal to
Okay. So now I can just cancel this. Okay. So now it will be yi
equal to
minus mxi minus b
minus
equal to
b.
0. Now what we are going to do here is we are just doing one step, that is dividing by n. Okay.
Okay.
I'll just divide the whole thing by n, right? Okay. So just a second. I just need to connect to my charger. Okay. 1 second. Yeah. So over here, if you see, you're having this. I'm just dividing by n. What is n? Total number of points. Okay.
Correct. I
So
N. Yeah.
yi by n minus m xi by n
Xi by n
minus
minus b by n.
b by n equal to 0. But if you remember, there will be something called as summation. Okay. This is summation. Okay. If you see here, what is this summation of yi by n? That means what? If you understand what is this, it is just add every value of y and divide by n.
Number
The
of total
whole
number of
y
points. Yeah.
column. The whole y
Correct.
column.
Average.
Correct. That means if you see here, that
Average.
where is that?
Yeah. Complete data set of points
Y
by total number of points.
the salary or package, you are adding them and dividing by n. That means what? You are taking average.
Yeah.
Okay. That average is represented by bar, y bar.
Okay.
Okay. In statistics class, we studied. So you will represent by y bar. Okay. Minus, if you see m
Mx bar.
constant, and this is mx. Xi means you're
Bar.
adding all these CGPA values and divided by n. That means x bar.
Input. Yeah.
Okay. And minus, if you see, this is what we are doing. This is just summing b n times. That means b plus b plus b plus
Yeah.
b n times. That means n times b by n.
Yeah.
That means what? B.
B.
Getting summing of b means n b plus b plus b
Yeah.
n
Yeah.
times. That means n into b
I
by.
equal to yeah. I
So
equal to 1 to n. So nb by n b.
b, correct. N b by b, it will be b. This is whole thing equal to 0. Okay. So
Yeah.
now, if you see,
Y equal to mx plus b.
yeah, b equal to nothing but y bar minus m.
Minus mx bar.
Getting?
Yeah. Now we got b.
Now we got b. Simple. So what is my equation of E? E is yi minus mxi minus b. Okay. So what
Yeah.
is E? E is my yi minus mxi. What is that? Minus b.
Minus
Okay.
b.
Whole square.
Minus b means minus of yeah.
So over here you are having yi minus
Minus
mxi.
mx
So b, I'll put this. Okay. Minus y
yeah.
bar.
Y bar
Correct.
plus mx bar.
Plus m x bar.
X bar whole square.
Whole square equal to 0. This is my E.
Yes.
So now that with respect to dou E by dou B is over. Now simple dou E by dou M.
Correct.
Correct? So now same thing. First bring this 2 down and yi minus mxi minus y bar plus
mx
mx
bar
bar into
into 0
internal.
minus
So now yi is
yeah,
0. Okay.
0
But
minus
now
m
you are doing with m. So this
xi
will be m
xi
with respect
xi
to, yeah, right, minus xi.
minus xi minus 0 plus
Minus
xi
0
plus x bar
plus
plus
x
x bar.
bar. Okay, equal to 0. Cool. So now it will be
2y, 2yi
2 into
minus,
yi minus, okay, y bar. I'm just writing yi minus y bar
okay.
together. And from here, if you see, you're
If,
having minus mxi plus mx bar. So if I take minus m common,
xi minus x bar
xi minus x bar, perfect.
into
Okay, into this is x bar.
x bar minus xi.
Okay, if you take minus common,
Mm-hmm.
okay, if you take minus common and I am multiplying that
Oh,
minus,
minus 2.
this will become minus 2.
Minus 2.
Okay,
Yeah.
and I am just removing this.
Into, you
We
can
have xi
just put it
minus
back. Yeah. Xi minus x
0.
bar
Okay, equal to 0.
equal to 0.
Okay, and you can just remove this. And if you
Yeah.
multiply, okay,
If you
if you multiply this with
x
this, what you are going to have? You are going to have yi minus y bar
minus y bar
into
into
xi
xi minus x bar
minus x bar. Okay, and minus m into xi minus x bar, xi minus x bar, xi minus
x
x
bar
bar
whole square
whole square. Okay, equal to 0. So
equal to
finally,
0. Yeah.
the m equal to, you can just, this term will go here and this will be divided by over here. Okay, that will be yi minus y bar into xi minus x bar. Okay, divided by xi minus x bar whole square. Okay, and you will have summation, obviously, yi minus y bar into xi minus x bar by xi minus x bar whole square. Getting? Simple. This will go this side and you will bring that xi minus x bar whole term to the denominator. Is this clear?
Clear.
Okay, so even if you see here linear regression, if you see m and b values equations, yeah, so y minus mx bar, okay, if you do the summation, the same thing whatever we got here, right? Okay, so this is y bar minus mx bar, whatever you are seeing is y bar minus mx bar for the old overall data points. And or if you see here, yeah, so b equal to y bar minus mx bar, you're able to see.
Oh, sorry. Sorry, sir. I was in mute.
Okay.
Yeah,
If you see
it's
y
correct.
equal to
Y bar
y bar
minus
minus
mx
mx
bar.
bar, what you got y bar minus mx bar, okay, and m
Yeah.
is xi minus x bar into yi minus y bar, okay,
Y
x
minus y bar
minus x
by
bar
x.
into y minus y bar by xi minus x bar whole square, xi minus x bar whole square. Okay,
Yeah.
so these are the two equations of my m and b, and our goal is this only, right, to find out the m
M and B
b. So now, but if you see here
using
interestingly,
this.
if you see here interestingly, the only thing I want is m and b. If you know the m and b, you will get the equation of the line y equal to mx plus b. And this is
Correct.
the this is not some random line. This is should be the best fit line. Why? Because I'm equating to 0. I'm doing the partial derivative. I'm equating to 0 such that my slope is equal to 0, which will give you the minimum value of the function. Clear?
Correct. Correct. So directly we are
So now,
finding
but
out
if
the
you
best
see
fit
here, no,
line.
no, no. But if you see here, when I calculated b, I'm having y bar minus mx bar. But the problem here is I know y bar. What is y bar? Simply the mean of the y. X bar, simply the mean of x. But m I don't know. From here, if you see m, all these values, if you see yi, do you know yi? Yes, yi is the input data point,
Actual point.
actual
Actual
point.
y point.
Y bar is the mean
Actual
of the
average. Average.
overall actual values. Xi is the actual data point, one single point. X bar is the total of values. Xi, same values. Query if you do and extend it for each and every data point. Simple
Correct.
calculation. Okay.
Yeah. For all, if you do for all data points, we'll
All
get
data points, you will
m.
get M. But the point is there is nothing that you don't know. Every value you know.
Correct. Yes.
Okay. Just put the values, do the calculation for all the data points. You are going to get the value of m.
Correct.
Once you get the value of m, take that. Here also you know y bar, you know x bar. You got m from here. Put that. You got b.
Correct.
Now you got m. You got b. Once you got y, m and b, and these are not some random m and b. These are the values which you got by equating it to 0. That means the value, whatever you're going to get y equal to mx plus b, that should be the best fit line.
Correct. Because
Correct?
we are already matching to the minimum value.
Correct. You're already doing the differentiation and equating it to the 0, such that you will get the minimum value of that function. And now this
Correct.
line, I can say should be the best fit line, because now if you take this line and calculate the errors, do this step, whatever you're doing right with this line. And now I can say if I put this line to the y equal to mx plus c, and if you replace this m and b with the values which we got, now I can confidently say this is not some random line, but this is a regression line or best fit line. Best
Okay.
fit line. Okay?
Yeah.
Yeah. Okay, that is the best fit line. Cool. So this is how you can do it by OLS. This is ordinary least square. Okay, because since we're using the
Yeah.
square method, okay, so it's called ordinary least square. Okay, I want the least value,
Well.
minimum value, and we are doing it by the square. But the problem is, just now I said we are having this, but what is the problem with this? This doesn't work for higher dimension. Why? Because if you see, for lower dimension, the equation of line will be y equal to mx plus b. Can you tell me what is the equation of the line? If you're having, see, you are having only one, what do I say, input value. That's why the equation of the line is this. Okay. But if you are having the more values, then
More than one feature. Yeah.
m1 x1, m2 x2,
Okay. Yeah.
m3 x3. Let's say you're having three input features plus b. It will be
Yes.
in three
Yes.
dimension. For each input feature, let's say this is CGPA, this is some gender. Okay. This is some experience. Okay. For some 9.8 CGPA score, and if she's female and if her experience is 3 years, what is the salary? For each of this feature, you will have corresponding slope, because this will be in one dimension, that will be in one dimension, that will be another dimension. Okay. So you need to
Correct. Yeah.
calculate this. Now, if you need to calculate this, okay. Now again, what you need to do? The equation you need to do multiple times of partial derivative. First, it will be b is only one, but for here you need to do dou e by dou dm1, dm2, dm3.
M2, M3. Three times related. Yeah.
Okay, then you will get three equations. Then you have to replace three to one in two. You will get one more equation, like that. You need to do complex calculation. It is still possible,
Yeah.
but the calculation is
Yes.
very, very complex. You getting?
Yes.
Lengthy. More than complex, it is
Correct.
lengthy.
Yeah.
Getting? And
Yeah.
and
Yeah.
in real life, let's say you are having, let's say, 10 features, 10 input features. Okay. As a simple example, you want to predict the house price, and there are like 10 features like facings, number of squares, number of rooms, etc. etc. Now, if you see this, the equation will be till m10 x10
Yeah.
plus b. Now you will get some 10 each equation for m. That means 10 equations for 10 m's plus one more equation for b. When you're
Yes.
doing dou m1, m2, m3, total 11. 11 equations you need to solve. It's very, very complex.
Yeah.
Agree? So that's why
Yes.
you have a very simple, efficient method called gradient descent. No matter what is okay equation, what is the order, it will easily give you the results.
Okay.
Okay. So I would
Yeah.
say that will be for today's class. I also want to cover the example also, but I would say it will become uh, too lengthy. Okay. Um, Fine. I would say, or do you want me to cover the example?
Uh, I mean, it's already lengthy. That's what
Oh,
I'm thinking.
okay, fine. Okay, so I would say that's for today. So I hope you understood the OLS part. And just to give you a summarization. So summarization, what we are going to do, we are going to just have this line. Okay, what is this? We just got some data points and we started with some random line. From there, we have framed the equations, and finally we got the, using the ordinary square,
M and B.
understood m and b. Now this m and b will give you
Yeah.
the minimum values of the e,
Yeah.
minimum, minimum values of b. Okay. Okay, fine. I would
Yeah,
say that's all for today, and we'll connect in tomorrow's class.
sure,
Okay?
Smita. Yeah.
Okay.